So the exam is going to cover these sections here. It starts with a section on hyperbolas. So you're going to be given a graph and asked to determine the equation. Now in this graph, you can easily pick out the a, that's 12. So that's going to be the denominator of one of these. By the way, which one am I going to choose? The first one or the second one?
The first one.
First one, good, because it opens up, so it has to be of this form. So a is going to be 12. And then you can figure out b from this one, c squared equals a squared plus b squared. And if you look closely, they actually give you the coordinates of this point. If I give you something like this, I give you a better graph. All right. But this is going to turn out to be a nice Pythagorean triple, so it's going to be 13 squared equals 12 squared plus b squared. B is going to equal 5. I just know that because it's a Pythagorean triple, comes up a lot. So overall, your final equation should look like this. It'd be y squared over 12 squared minus x squared over 5 squared equals 1. And that would be your winner. You could write that as 144 and 25 as well, but I'd be just as happy to see it as being something squared. Same kind of problem with a little bit less visuals here. Again, that's telling you, your A, and that's going to tell you your C, and then you're just going to use this formula again. Now, what's the difference between this formula here and this formula if this was an ellipse?
It would be subtracted.
Yeah, you'd have a subtraction. Good. This one here, where they give you the asymptotes, the coefficient of x in the equation for your asymptote is really the denominator of your y term divided by the denominator of your x term. That's going to be your slope. So that's going to be your m. In this case, m is 3, so you can think of that as being 3 over 1. So m is 3 over 1. And that's where you get the 1 for the x and the 3 for the 9. So, and it has a center at 0, 0. Let's keep going. There's a huge difference between this one with a plus and this one with a minus. What would this graph be if there was a minus here? Well, that'd be a hyperbola. Good. As it is, with the plus there, it's going to be an ellipse. So you start out with your center. Center is at 1 and 3. And then your vertices. Well, you might want to rewrite this a little bit as, say, x minus 1 squared over 5 squared plus y minus 3 squared over 2 squared equals 1. And then to find your vertices in the x direction, you're going to move to the left 5 and to the right 5. So 1 minus 5 gives you negative 4. 1 plus 5 gives you 6. Notice you're just changing the x coordinate. The y coordinate stays the same. To find your foci, it's going to be c squared equals 5 squared minus 2 squared, which is 21. So c is going to be the square root of 21. Now again, your foci is going to be on the major axis. It's going to be on the longer of these two axes, which is going to be this one. So you take your center and move square root of 21 to the left. So 1 minus the square root of 21 at the same y height. And then 1 plus the square root of 21 at the same y height. Yay. Major axis, minor axis, that's just the length of these things. So here's your graph, 1 and 3. Yeah, 1 and 3, about right there. That distance is 10, that distance is 4. That's the length of your major and minor axes. Okay. Let's do another one. Now, the center is something that I drew in. You're going to have to look along the x-axis here and say, okay, well, the midpoint of that is going to be 6 and 0. If I plug that in here, that's going to be x minus h, which is a 6, divided by that distance, which is 5, squared. Numerator has to be squared too. This is your h, that's your k. It's going to be y minus 0 squared divided by, well, that looks like a distance of 4. So 4 squared equals 1. Now you can get rid of the minus 0, just write it as y squared over 4 squared. That's fine. That's what they actually do in their version of the answer. They just leave it as y squared over 16. That's fine. This one's kind of a good one. I think I gave it a hint out when I went through this earlier, but this part right here, you can start out by determining your h and k. By the way, it has to be an x squared term, which is your positive term, because it's opening around the x-axis or parallel to it. So your center is going to be at 6 and 0, so it's going to be x minus 6 squared over a squared, and then y minus 0 squared over b squared. A we can figure out because that's that distance right there. Looks like a distance of 4. So a equals 4. Is that right? No.
Isn't it
that's
3?
3. Yeah, it's 3. A is going to be 3. Yeah. Yeah, because that's... All right, so a is 3. 3 squared. But that leaves you short in determining what b is. So we have to figure out, well, how are we going to figure out what b is? You can clean up this equation a little bit. If you wanted to, you could write it as x minus 6 squared over 9 minus y squared over b squared equals 1. But there's a little something that we can use here. Let me rewrite that. 6 squared over 9 minus y squared over b squared equals 1. And that trick is that this passes through the y-axis at the point 0, 6. So I can put in 0 for x and 6 for y. At that point, the only thing unknown is going to be b. So let's see what happens when I do that. So let's see, it's going to be 0 minus 6 squared over 9 minus 6 squared over b squared equals 1.
And is this for trying to find b?
That's for trying to find b.
Okay.
So that's a b squared, even though it looks pretty beaten up. So it's going to be 36 divided by 9. Well, that's just a 4. Minus 36 over b squared equals 1. I'll subtract 4 from both sides and get negative 36 over b squared equals negative 3. If I multiply both sides by b squared, I'll end up with negative 36 equals negative 3b squared, or 12 equals b squared. Yay, and that's what I really needed. I needed b or b squared. I could just write a 12 here and be done with it, or I could write it as the square root of 12 quantity squared. I think the WebAssign just went for putting in a 12 in the denominator and calling it a day. So overall, your answer would be x minus 6 squared over 9 minus y squared over 12 equals 1. That would be your final answer on that one. Yay. All right. So another one here where they give you the center. This one's going to be an ellipse. They actually gave you the center. They didn't really need to. You should be able to figure that one out. The center is just going to be directly between V1 and V2. Notice that V1 has a negative 2 in it. It's kind of spilled over on a word wrap, so it doesn't quite look like negative 2, but it is. But halfway between this point and this point is your center. And there's your foci. The center gives you the distance of 10. Figure out the distance of B. All right, center gives you, let's see, that'd be the x direction. Ah, boy. So it's going to look like this. X minus 3 squared over, let's see, the distance to V2. Yeah, it's going to be 10. 10 squared plus y plus 2 squared over b squared equals 1. And then you're going to figure out b with this formula. Another Pythagorean triple, you'll end up with 8. Conic section. With your parabola with a vertex right here at -3 and 6 and a directrix at y equals 4, this parabola has no choice but to open up. If it opens any other direction other than up, it's going to cross its directrix. So if it opens up, which term is going to be my squared term? The x squared term or the y squared term? It has to be a parabola in x squared. So it's going to be x minus h squared equals 4 times p times y minus k. H and k are going to be your vertices. So I know that. That's my h and that's my k. So it's going to be x minus -3 squared equals 4 times p times y minus 6. The only thing left to do is determine p. P is going to be the distance between your vertex and your directrix, or going the other way, your vertex and the focus. So if I move up 2, I'll have a focus at -3 and 8. But if I put in a 2 here, then I end up with this equation, x plus 3 squared equals 8 times y minus 6. And that's your equation for this one. On the bottom of your handout, the very, very bottom of this handout, I've given you the which conic am I. That's probably a more likely equation or question than most. So let me see if I can't find that here. There we go. So the big thing is that you should be able to recognize what these are without writing them down. Now I kind of regret that I gave you such small numbers here. You can put that in Desmos, which will be available to you on the exam. But this one, you'd have to be pretty talented with Desmos to get a good graph out of this. All right? And I don't think most people are going to want to spend the time. But it doesn't matter. All I want to know from this is what conic section it is. And this one has to be a clear choice. What conic section would that be?
Parabola, the one square term.
Yep, a parabola. Nice. And again, the one down below it. This would probably be a really tiny graph. Again, it would take a lot of talent to get this one in the right shape. But as far as telling which of the 4 conic sections, hyperbola, parabola, circle, and ellipse, again, that one should be pretty easy. Which one is this one? Yeah, that has to be a hyperbola. That's because these terms, the coefficient of my x squared and my y squared terms, are opposite in sign. All right? Everything's over on the left. And these are opposite signs. It has to be a hyperbola. And that's just kind of branching down over here. Are A and C opposite in sign? Yeah, it's a hyperbola.
Question.
Go ahead.
Why was the first equation a parabola again?
All right, so going back,
Because it wasn't squared?
there's only one term that's squared. That's what made it a parabola. So how about this one then? Let's see if we can't figure out this one, and then we'll complete the square on this one as well. So 4x squared plus 25y squared minus 24x plus 100y plus 36. It can't be a hyperbola. Why not?
Because the 2 square terms have the same sign, both positive?
Yep, they're both positive, right? So it's not a hyperbola. They would have to be opposite in sign. So it's not a hyperbola, it's not a parabola. It's either an ellipse or a circle. Now if it was a circle, this coefficient and this coefficient would be identical. They're not. So it has to be an ellipse. Again, you're done. Now, as far as the rest of that is concerned, and maybe you'll have to come back and watch the video to see this, but here's the work in completing the square for that kind of a mess. So what I did here to start is I said, you know what? I'm going to bring my x's together and my y's together. So I did that. Now, as far as completing the square, you have to have a coefficient of 1 when you complete the square. So I factored out the 4 from those two terms. So factored out the 4 from those. And I factored out the 25 from the other two terms. The big thing that people do that screws them up on this is they factor out the GCF. They factor out 25y. No. All I need to factor out is the 25. Completing the square is something we've been doing since last semester. You take half of the middle coefficient and then square that number. That's what you complete the square with. Don't forget that when I put a 9 here, I'm really adding 4 times 9 is 36 to the left-hand side. So I did the same thing to the right side. I added 36. 25 times 4 is 100, which is where I got the 100 there. Those terms break down into perfect squares now. Divide both sides by 100, and then you get the rest from there. You can write that as 5 squared and 2 squared respectively, but once you're down to here, you're golden. Okay. Let's move on down to section 12.1. Wouldn't be surprised to see a recursive sequence on your exam. So just a reminder, this is defined kind of implicitly. They don't give you an exact formula. I can't calculate a sub 1000 just by plugging in. I'd have to know a lot more before I could get up to a sub 1000. Let's go back here to that part of the handout. And there we go, right here. Maybe it's a little easier to see here. But what you're going to do to get any one term, you're going to plug in the previous term. So I think a couple of people got this one wrong on the homework because they accidentally started out putting in an 18. A sub 1 they give you. A sub 1 is 5. But if I want a sub 2, that's going to be 2 times a sub 1 plus 4, which is 2 times the previous term plus 4 times 2, 18. Plug in the 18 here to get a sub 3. So that's a sub 2 is 18. 18 plus 4 is 22 times 2 is 44, and so on. If I want a sub 3, what do I need to know? Or if I want a sub 4, I need to know a sub 3. So 2 times 44 plus 4, that's going to be 48 times 2 is 96, and so on. You can program your calculator to do this stuff for you if you're a little nervous. That's fine. Is it worth me taking a minute to show you how to do that or no? Yeah? All right. So let's go over to our graphing calculator. The first thing I need to do is put my mode into sequence mode. So if you hit the mode key, go down to function, then across to sequence, and like that. Now, when you're done with this section and done with this course, you probably want to put this back into function mode. But for right now, we're where we want to be. I'll hit the y equals key, and I'll clear out the stuff that's already there. So my formula says I want to take 2, and we're defining u sub n, not a sub n. So that's why I'm going to use a u here. 2 times u sub n minus 1 plus 4. So where do I get u? That's right above the number 7 key. So I'll hit the second key, then the 7 key, u sub parentheses n. Notice that because we're in sequence mode, that I get an n as opposed to an x when I type that key. Minus 1. close parenthesis, plus 4, enter. And the first term is a 5. Beautiful. So with that set, then I can go to my table. And I'm going to take just a quick second to make sure that my table setup is still set the correct way, that I like it. So if I hit the second key and then the window key, perfect. I want independent set to ask and dependent set to auto. The other settings don't matter. Let's go to table, second graph. I can delete this stuff. If I type in a 1, the first term is a 5. All right, that makes sense. Second term, third term. The nice thing about this is I could ask you, say, for the 50th term. Now, it might take a minute or so, but there you go. Now, I'm only seeing 7.3 E15. If you want more of the digits, cursor over here. So that's, let's see, millions, billions, trillions, quadrillions. That's 7.3 quadrillion. That's huge. So it'd be really, really big. Nice of our calculator to do that for us, though. Let's continue. I would expect something like this. In fact, I would expect something like this with alternating terms. So they start out positive or negative, and I'll go back in that in a minute. Partial sums, this is a gimme. If I put this on an exam, that's giveaway points. It's just asking you, S sub 3 is asking you to sum up the first 3. S sub 4 is asking you to sum up the first 4 of those terms. And then S sub 5, S sub 6, etc. That's giveaway points. Don't miss those. Make sure you can expand a sum. Now, just so you know, there is an urban legend about a student handing in a test where he was told to expand the sum. And this was his answer. And then this. All right, that's not quite what I mean when I say expand the sum. That's more of what an English major would give me. No slight against them. All right. This one. If you notice here in the notes, for your review, I took time to actually explain this a little bit. So if you were asked to find a sum like this, what I'm testing you on is, can you count the number of terms in this sum? Because this is really 12 plus 12 plus, 12 a bunch of times. But how many times? Well, it turns out that it's the top number, 15, minus a bottom number, plus 1. That gives you 9. So if I have 9 12s, 9 times 12, that's 108. So not a hard problem. It's just asking you that you know this little fact here. Let's keep going. I hinted at this with one of the problems that you could be given, as to find the general pattern of a sequence, something like this. I'd probably make it alternating like this. That means you have to decide, do I want to include a -1 to the n term or -1 to the n plus 1 term? This one is going to start out with a negative. Starts negative. Because if I put in a 1 here, I get -1 to the first power. That's -1. If I put in a 1 here, -1 squared is +1. So do you want to start out with negative, positive, or positive, negative? One of those two terms is going to be the correct term for you. Arithmetic sequence, you should definitely have a bunch of formulas memorized. A sub n is a sub 1 plus n minus 1 times d. That one gets you out of a lot of trouble. In fact, a sub 1 here is 9, d is 2. That's great. That's your first term. That's your common difference. Wow. Take a look here. Here's your common difference. 9, 11, 12, or 9, 11, 13, 15, 17, 19, etc. Common difference of 2. So in this particular problem, they gave you a sub 1 is -9 and d is 6. So this is what's given. That makes a sub n this. And if you want the 10th term, just plug in a 10 here and get The 10th term is 45. Right, that doesn't look right. Oh yeah, that would be right. Okay. How do you find the common ratio? If you're looking for a geometric sequence, looking to see the geometric sequence, then a sub 2 divided by a sub 1, that'd be 12 over 10. Let's compare that to a sub 4 divided by a sub 3. A sub 4 would be 24 over 16. That reduces to 3/2. This reduces to 6/5. Since those two aren't, oops, I'm sorry, I didn't realize I was zoomed out. Since these two ratios are different, this can't be a geometric series. In fact, if you looked at it, it's not even an arithmetic series. You're not going up by a steady amount each time, so it's neither. That would be a D&E. This one's a gimme. Again, if I put a test question like this, you know, what's the common difference? That's pretty, you can do that by looking at it. It's just 8 to get from one term to the next. The 5th term, add 8. Again, a gimme, 1 point, 1 point, maybe 2 points here. Again, going back to a sub n is a sub 1 plus n minus 1 times d. So that'd be 2 plus n minus 1 times 8. N minus 1 times 8. Yeah, nothing really deep there. And once you got that formula, you can figure out a sub 100. Beautiful. You should expect one where you're going to have to kind of reverse engineer this formula for a particular sequence. So in our case, the 50th term is 746. Okay. And the common difference, is 5. So if the common difference is 5, let me put that in right away. So it's that. And then I'm going to put in that the 50th term is 946. So that means 946 is a sub 1 plus 50 times n minus 1, or 50 minus 1. So if you solve there, you'll get a sub 1 is 701. First term of a sequence is 3510. Common difference is negative 16. Beautiful. Which term of the sequence is 2806? Well, take 2806, plug it in here, and then solve for n. You should get n equals 45. This one I kind of like. So you're given a sequence, a series, and you're supposed to add it up. The question is, how many terms do I have here? I mean, I got these two great formulas that, by the way, should be memorized. Both of those. But both of them require that I know an n. I have to know what number of the sequence that is. So go back to this tried and true formula right here. A sub n is a sub 1 plus n minus 1 times d. And plug in all the known information. For instance, the first term is 230. The common difference is negative 12. Solve for n. Once you have n, then I can plug in n here. The first and last terms are 230 and 122. You should be able to solve and get that s is 1760 from there. 12.3, another general formula that you should know. A sub n is a sub 1 times r to the n minus 1. That one gets used off a lot. In fact, it might not be a bad thing to do to start off your test by writing down a few formulas, like this one right here. Write it right at the top of your test. write this one right at the top of your test. Before you can forget it, write it down so that way you have it. When later on you find a problem that needs it and you're in a panic, you're like, what's that formula? Oh, whew, I got it written down. You know, these would be good to have as well. We'll put a little star by that. All right, so a sub 1 in this one, they put an A. I like to call it a sub 1 as a reminder that it's the first term. 3/2, r is negative 1/2 to the n minus 1. Looking good there. Then with all this, if I want to find the fourth term, I just plug in 4 and get 3/2 times negative 1/2 to the n minus 1. That's going to be to the third power. So I'll end up with negative 3/16. Okay. First 4 terms of sequence. Again, this is going back, showing you what you can do to figure out what a common ratio is. If I take this and divide it by the previous term, or this and divide it by its previous term, I get the same number each time. Technically, I should probably do it for this too as well, but they already told us that we need to determine a common ratio. I don't think they're going to try and trick us by having something change up there. This is a geometric series, or I should say sequence. So we determined R. Notice that R is the same for both of these. It should be. So your general term is going to be a sub n equals 0.9 times negative 0.9 to the n minus 1. And from there you can figure out the fifth term in a couple ways. You could plug in 5 here. What's another way to figure out the fifth term of this sequence? You could just multiply the fourth term by negative 0.9. That'll give you the fifth term. Again, here's another one where I said, all right, look, expect something more than just the first 5 terms here to sum up. Now, I can do one of two things in giving you a problem like this. I could just go easy on you and give you some simple numbers and be very, very clear that I want you to show me how you use the formula, or I could just make this really, really big and force you to use the formula. People aren't really good at complying with my request to show me the work, so I'm leaning towards the latter. But if I wanted the sum of the first 5 terms, that'd be s sub 5. It would be a sub 1, which is 8, times 1 minus r, which is 2, to the 5th power, over 1 minus 2. That's it. They're just asking you to use that formula. So again, that's another formula that maybe you want to have memorized. So let's star that one. Now what's nice is that you can actually use this formula when n is infinity, provided that the absolute value of r is less than 1. So s sub infinity is a sub 1 over 1 minus r. If r is less than 1, then you can absolutely find an infinite sum. So in this case, a sub 1 is 4/5. R is also 4/5, so it'd be 1 minus 4 over 5. And I'll let you double check me on your calculator, but that sum is going to turn out to be 4. So if you add this plus this plus this, on and on forever, it would be 4. Unfortunately, the one below it doesn't work. The one below it diverges. It doesn't add up to any finite total like we had just a minute ago. How do I know that? To get from one term to the next in this sequence, what am I multiplying by?
1.1 is greater than 1.
Yeah, so I'm multiplying by negative 1.1, If I take the absolute value of that, that's greater than 1. Therefore, that's the 3 little dots there, therefore it diverges. Okay. Pascal's triangle. You should be able to write down as many rows as I want. I'm only going to want maybe 5 or so rows. But you should know Pascal's triangle. That helps you calculate things like this. Expand that using the binomial. And again, be careful not to expand it this way. That's only good for one partial credit point if all else fails. Hopefully you're going to get that by expanding. You're going to use the coefficients from Pascal's triangle. So that would be this level down here of the a plus b to the 4th. You could also do that with the binomial theorem. You should be able to find these numbers from your calculator. So a lot of times I do some interesting ones like 52, choose 5. That's the number of possible 5-card hands you could deal out of a deck. It's just a little bit less than 2.6 million. You could also write that as 52, choose 5 like that and get that from your calculator. So kind of real quickly, review that. Let me quit this, clear here. So I'll type in the number 52, then go to the math key, over to probability, third option down, 52, choose 5, a little less than 2.6 million. There you go. 2,598, 960. Beautiful. And last but not least, one of the tricks I showed you was, how to find the coefficients of, say the first 3 terms. I don't feel like doing Pascal's triangle all the way down to the 14th level. That would be a pain. So instead what I'll do is I'll do this. It'll be 2x to the 13th power plus 2x to the 12th power, and then negative 1 to the 1st power plus 2x to the 11th power and negative 1 to the 2nd power. Now those are the basic terms. I need to come up with the coefficients. So coefficient here is always 1. The next coefficient is always that power, right? 13. So I get 2 of those almost for free. And then last but not least, you can either do this as 13 choose 11, or excuse me, not 13 choose 11, 13 choose 2 will give you the right one, and that would be, I think, 78. Or you can work it this way. It's going to be this exponent, the exponent of your a term, times this coefficient divided by the fact that this is not the first term but the second term. So 12 times 13 divided by 2 gives you 78 times 2 to the 11th, x to the 11th, negative 1 squared is just 1. So I'm not really interested in making you write out 2 to the 11th, which I think is 2048 times that. The idea is that you just be able to expand it like this. But do expect something like this as well. That one, or better yet, this one, where you have a negative to deal with. Those are prime candidates for a section 12.6 problem. Okay, I think I've gone over a little bit. Hopefully you kept up with things. And see you.